to find these solutions for a quadratic equation. First question, and only question for this section. Negative 3x squared minus 5x plus 2 equals 0. To use the quadratic formula, you have to have a polynomial equal to 0. If it's not equal to 0, you have to change it so it's equal to 0. The values, the number in front of x squared, a would be negative 3. The value in front of x, b, would be negative 5. And the last number, c, would be positive 2. Plugging these numbers in, we'll have x equals negative from the equation. B is a negative 5. So I have a minus 5 plus or minus the square root. B squared, b is negative 5 squared, minus 4 times a, which is negative 3, and times c, which is 2. All divided by 2 times a, which would be 2 times negative 3. Simplifying from here, x equals a minus 5 would be positive 5, plus or minus the square root, negative 5 squared would be 25, negative 4 times negative 3 would be 12, 12 times 2 would be 24, and it would be a positive 24. 2 times negative 3 would be negative 6. Solving from here, 5 plus or minus the square root, 25 plus 24 would be 49, all divided by negative 6. X equals 5 plus or minus the square root of 49 would be 7, all divided by negative 6. From here we can get two answers. The first answer would be 5 plus 7 divided by negative 6. And the second answer would be 5 minus 7 divided by negative 6. 5 plus 7 would be 12 divided by negative 6 would be negative 2. And the second answer, 5 minus 7, is negative 2 divided by negative 6. Reducing fractions, and that would be 1/3. So the two answers to the equation using the quadratic formula is negative 2 and 1/3. Finding and using the discriminant. The discriminant is part of the quadratic formula. It is the part that's underneath the square root sign, which is b squared minus 4ac. If the discriminant, which is b squared minus 4ac, is greater than 0 or a positive number, then the equation will have two real solutions. If the discriminant is equal to 0, b squared minus 4ac equals 0, then you'll have one real solution. Because you take the square root of 0, you only have one answer. And the last part, if b squared minus 4ac is less than 0, which is a negative number, you'll take a square root of a negative number, and you'll have two imaginary solutions for the answer. First equation, and only equation for this section, is 2x squared minus 16x plus 33 equals 0. Using the discriminant, we can tell whether this equation has two real solutions, one real solution, or one imaginary solution. Again, the discriminant from the quadratic equation is b squared minus 4ac. Finding the discriminant, b is negative 16, so we'll have negative 16 squared minus 4 times a, which is 2, times c, which is 33. Negative 16 squared would be 256. And negative 4 times 2 will be negative 8. Negative 8 times 33 will be negative 264. Subtracting 256 minus 264, we'll have negative 8. So the discriminant b squared minus 4ac is a negative number, or negative 8, which is less than 0. So this equation would have two imaginary solutions. So again, using the discriminant, we can tell what type of solutions we would have, and this question would have two imaginary solutions. Graphing a parabola in vertex form. The vertex form equation is y equals a, and inside parentheses x minus h squared plus k. From the vertex form, we can find the vertex, axis of symmetry, and direction. The vertex is the coordinates h comma k. The axis of symmetry is x equals h, and the direction will be up if a is greater than 0, or down if a is less than 0. Title of the first section is Graph in Vertex Form. In this section, we'll take equations in vertex form and graph the parabola. First equation, y equals 3. Inside parentheses x minus 3 squared plus 2. From this equation, we can find the vertex. The vertex x comma y. If we look inside the parentheses, the number after the minus sign will be the x value, or you can also take the opposite. If it's x minus 3, x would be positive 3. The y value k, the last number, positive 2, stays the same, so the vertex would be 3, 2. The axis of symmetry, which is the line down the middle of the graph that makes the graph symmetrical, will be the same as the vertex and the same as the h value, x equals positive 3. And last part we can find from vertex form is the direction, which will either be up or down. Looking at the value of a, which is the number outside the parentheses, if we have positive 3, the direction of this graph would be up. Graphing from here, we can draw the xy axis. Our vertex is at 3, 2. If you want to, you can draw the axis of symmetry, which is the dashed line going through the vertex. That makes the graph symmetrical on both sides. And last part, the parabola shape will go up. So we'll sketch the graph going through the vertex and pointing up, and that would be the graph for the section. Second question, and last question for the section. Y equals negative 1/3 in parentheses x plus 1 squared minus 3. Again, this equation is in vertex form. We can find the vertex of the parabola. The vertex, if we have x plus 1, the opposite would be minus 1. And the y value stays the same, minus 3. The axis of symmetry. X equals the same coordinate as the vertex, or the same value as h. X equals negative 1. And last part, direction. Looking at the value of a, or the number in front of the parentheses, negative 1/3, the direction of this graph would go down. Sketching the graph for the equation. The vertex, negative 1, negative 3. The axis is symmetry. If you want to, you can draw the dashed line through the vertex. And last part, the parabola opens down. So sketch the parabola shape opening down. And that would be the graph for the equation. Title of the last section today is Changing an Equation to Vertex Form. In this section, we'll take a quadratic equation and change it or rewrite it in vertex form. The definition or way to do that will be to complete the square. By completing the square, we'll be able to change an equation into vertex form. First equation for the section, y equals x squared minus 6x plus 1. To complete the square in the section, we can rewrite y equals, and we'll have x squared minus 6x, and to that we'll add a blank spot or a number in which we'll complete the square. Putting this first part in parentheses, this will be our factored form. The plus 1 we'll put outside the parentheses. When you complete the square to solve an equation, we'll add the same number to both sides. For this one, we want to leave y by itself, so instead of adding the same number to both sides, we'll add the number inside the parentheses and also subtract that same number outside the parentheses. So we'll add one number and subtract that same number, which will cancel out. The equation for complete the square, if you remember from previous sections, is b over 2 squared. B value for this equation is negative 6. So we'll have negative 6 over 2 squared. Negative 6 divided by 2 would be negative 3. Squaring negative 3 will have the value of 9. So we'll add 9 inside the parentheses, and we'll also subtract 9 outside the parentheses. Factoring from here, we have x squared minus 6x plus 9. You can use a diamond method to factor, or if you remember the shortcut for complete the square, the number inside the parentheses will be the same number inside our factored parentheses, which is minus 3. So x minus 3 squared is the factored form of x squared minus 6x plus 9. Outside the parentheses, we'll have a plus 1 minus 9, which if you simplify is negative 8. So our final answer in vertex form, y equals x minus 3 squared minus 8. Second equation and last equation for the section, y equals negative x squared minus 4x plus 8. Again, we'll take this equation and rewrite it in vertex form. When you complete the square, if you remember, the a value has to equal 1 or positive 1. Right now it's equal to negative 1. So before we complete the square, we'll cancel this negative 1 out or factor a negative 1 out. Factoring a negative 1 out will give us x squared. Factoring a negative 1 from the negative 4 will be positive 4x. The plus 8 we won't factor a negative 1 out, but instead we'll add the missing number we'll get in just a minute, and the plus 8 we'll rewrite on the outside. Also, the number we add to the inside will be subtracting on the outside. From here, we can figure out which number we're going to add to the equation to factor it. And again, the equation is b over 2 squared. B is equal to 4, so we'll have 4 over 2 squared. 4 divided by 2 would be 2, and 2 squared would be 4. So we'll add 4 inside the parentheses. Instead of adding 4 though, what we're actually doing is adding 4 times a negative 1. So we're adding 4 or adding negative 4, which is the same thing as subtracting 4. If we're subtracting 4 inside the parentheses, we'll change this one to addition and add 4 on the outside. So negative 1 times 4 would be negative 4. The positive 4 on the outside would cancel with the negative 4. Factoring from here, negative 1 would stay the same. Factoring x squared plus 4x plus 4. You can use the diamond method or the shortcut. The number inside the parentheses, positive 2, will be the factored form x plus 2 squared, 4x squared plus 4x plus 4. And a positive 8 plus 4 would be plus 12. So our final answer in vertex form, y equals negative 1, x plus 2 squared plus 12. Title of the first section today is Graphing, Quadratic, Inequalities. Graphing quadratic inequalities, instead of an equal sign, we'll have an inequality for the equation. First question. Y is greater than or equal to x squared plus 3x minus 18. There are several ways to graph this problem. We can either use the equation negative b over 2a. We can also try and factor it. We could use a t-table or any of the other methods. For this question, we can find the vertex by using negative b over 2a. Negative b would be negative 3 divided by 2 times a, and a would be 1. So the x value of the vertex in this question would be negative 3 over 2. Plugging this back in, we can solve for y. X squared, or negative 3 over 2 squared, plus 3 times negative 3 over 2 minus 18. Solving from here, negative 3 over 2 squared, we'll square the numerator and denominator. Negative 3 squared would be 9, and 2 squared would be 4. So we'll have 9 over 4. 3 times negative 3 halves. You can make each of these fractions and then multiply straight across. 3 times a negative 3 would be negative 9, and 1 times 2 would be 2. and minus 18 would stay the same. Solving from here, we have y is greater than or equal to. Getting common denominators, we can leave 9 over 4 the same. 9 over 2, we can rewrite this 4 by multiplying by 2. So we'll have minus 18 over 4. And the negative 18, we can also write with a common denominator. If we have 18 over 1, we can multiply numerator and denominator by 4. And that would give us negative 72 over 4. Simplifying, y is greater than or equal to 9 minus 18 would be negative 9, and negative 9 minus 72 would be negative 81 over 4. Taking the improper fraction, if we divide it out using a mixed number, so we can graph it, 4 goes into 81 20 times. There's 1 left over, so that would be 20 and 1/4. It is negative, so we'll have negative 20 and 1/4. So the vertex for this parabola will be negative 3 over 2, and the y value negative 20 and 1/4. The second part to graph, we can find the direction. Looking back at the original equation, we had a positive x squared, so the direction would go up. We can also find the y-intercept. If you remember, the y-intercept is the value of c in the original equation, which would be negative 18. Graphing from here. Our x value is negative 3/2. And the y value is negative 20 and 1/4. So going down 20 spots and a little bit past, that would be negative 20 and 1/4. And the x value would be at negative 3.5 or negative 1.5. The y-intercept is at negative 18. And the direction of this parabola goes up. Looking back at the original inequality, it is greater than or equal to, which means it is a solid line for the graph. And the last part for an inequality is shading. We have y is greater than or equal to the equation. The greater than y's would be above the graph, or in this case, everything inside the parabola. And that would be the graph for the section. Second question, and last question for the section, is y is less than x squared plus 4x plus 4. Again, there are several ways to graph this quadratic equation. One method we could use is factor. If we factor this equation, x squared plus 4x plus 4, the two numbers that multiply get 4 and add to get 4 would be x plus 2 and x plus 2. Rewrite. After factoring, if you remember from previous sections, we can set these factors equal to 0 to find out the x-intercepts or solutions to the graph. So the first parentheses, x plus 2 equals 0, and the second parentheses will be the same, x plus 2 equals 0. Solving each one of these, we'll get the same answer twice, x equals negative 2. If you get the same answer twice, that means there's one solution to the graph, negative 2. It's called a double root, since the root repeats. Graphing the one solution at negative 2, that would be the only x-intercept, which means the vertex will be on the x-axis at that point. We could also do the y-intercept from the original equation, which was positive 4, and the direction goes up since we had positive x squared. Also, the inequality was less than, Less than would be a dashed line. So we'd have a parabola going through the vertex and the y-intercept, but it would be a dashed line instead of a solid line. And we had y is less than the equation. Y is less than means we want the smaller y values, everything on the bottom of the graph, which would be everything underneath the parabola. And that would be the graph for the question. Title of the last section today is Find the Solutions Using a Graph. Given a completed graph, we can find the solutions, which are again where the graph crosses the x-axis or the y value is equal to 0. First equation or first graph, we have an inequality graph. The 2 points that cross that on the left hand side is -2 and on the right hand side is +2. If this was a equal equation with not shaded, our two answers would be -2 and 2. Since the graph is shaded and the points are shaded between the 2 points, our answers will be everything between -2 and +2, which you can write as -2 is less than or equal to x is less than or equal to +2. So including the points -2 and +2, all the numbers in between are also solutions to the graph. Second graph and second equation. On this graph, it crosses the x-axis at one point, which would be the vertex, and that point is at +4. Since there's only one point and no other point on the x-axis is shaded, the answer to this graph would be x equals 4. And last section, last problem for the section. We have a graph that crosses the x-axis twice. One point is at -3, and the second point is at +3. And the shading for this graph is on the left side and right side. So we want the numbers less than -3 and greater than +3. So our answer would be x is less than -3 or x is greater than +3. The graph does not include the points, so it's not or equal to, since it's a dashed line.